Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Haziq bin Muhammad MASONI, and I will be doing the Lab 4 video assignment, which is on DC motors. So first of all, what is a DC machine? Well, a DC machine is an electromechanical energy conversion device. DC machines, they come in two types, which is a DC motor and a DC generator. A DC motor works by converting DC electrical power into mechanical power, while a DC generator is the opposite as it converts mechanical power into electrical power. Alright, so what is a DC motor? So as I said before, DC motor, it works by converting electrical energy into mechanical energy. It's the most common motor found in household items. Examples of household items using a DC motor is, for example, a ceiling fan and also a vacuum. DC motors are advantages as the speed at which they spin can be controlled. So, for example, if you use, as I said, a ceiling fan uses a DC motor, you can control the speed of the ceiling fan by regulating the speed of the DC motor inside. So here we have a DC motor construction. This is the inside of a basic DC motor. Basically, every DC motor has what's in here. So here we have the shaft, which is in the middle. We have the armature conductors. We have the field winding. Um, we have the pole shoe. We have the yoke, or also known as the frame. We have a commutator, and we also have interpoles. So what do each of these components do? Well, first of all, the shaft. The purpose of the shaft is to convert energy from the motor into the end-use application. So if you see here in a previous picture, you see here, this is the shaft. And all the components inside, they work by spinning the shaft inside here, which in turn spin the shaft out here, which will be connected to whatever needs to be spun. Say, for example, the blades of a fan, of a vacuum. Yeah. So next off, we have armature conductors. The armature conducts AC even on DC current machines using the commutator, which reverses the current direction every so often, or it's also due to electronic commutation. Right? So the purpose of the commutator is to ensure that the current flowing through the rotor windings is always in the same direction, and the proper coil on the rotor is energized in respect to the field coils. Next, we have the field windings. Field windings is the insulated current carrying coils on a field magnet that produce the magnetic field needed to excite the generator or motor. As each coil is energized in turn, the rotor aligns itself with the magnetic field produced by the energized field winding. Alright, so now we have the pole shoe. The function of the pole shoe is as shown. It supports the field coils. It spreads out flux for better uniformity, and it also reduces the reluctance of the magnetic path. Yoke. A yoke, or the outer frame of a DC generator, it serves two purposes. It holds the magnetic poles or cores of the generator and acts as a cover of a generator. So basically the yoke or the frame, it works as a casing. It protects the inside components of a DC motor. Uh, yeah. And lastly, we have the interpoles. Interpoles are designed in DC motors to overcome the effects of the armature reactance and the self-induction of the machine. And interpoles can also counter and cancel reactive voltage in the coil undergoing commutation. So here we have four types of DC motors here. We have firstly the permanent magnetic DC motors as shown here. The permanent magnet DC motors, they use a permanent magnet motor to create field flux. So inside here, there's a permanent magnet. It's always going to be magnetic, and that is what is used in the motor to create field flux. Permanent magnet motors, they have high starting torque and good speed regulation. However, that high starting torque is limited, and that's why it's used in many household applications. Next, we have the series DC motors. In the series DC motors, the field is wound with a few turns of a large wire carrying the full armature current. It creates a large starting torque but cannot regulate speed. So, as opposed to their permanent magnet DC motor counterparts, this one cannot regulate the speed. It can also be damaged if it runs with no load, and that's why it's not recommended for variable speed drive applications. Next, we have shunt DC motors. In shunt DC motors, the field is connected in parallel, where this is where the shunt name comes from, with the armature windings. It offers great speed regulation because the shunt field can be excited separately from the armature windings, and it also offers simplified reversing controls. And lastly, we have number four, compound DC motors, which, like its shunt DC motor counterparts, it has a separately excited shunt field. Compound DC motors have good starting torque, but they may experience control problems in various speed drive applications. And that's all from my side of the chat. I will now move on to my member Nazhan, and thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAZHAN bin HANAFIAH. My matrix number is 2120-21410. I would like to continue our presentation. Why DC motors need speed control? DC motors play an important role in energy conversion. This is just like any other machine which convert electrical energy into mechanical energy. In a mechanical system, the speed varies with the number of tasks, so speed control is required for proper mechanical work to make the motor run smoothly. Why is it important? This is very important when you start and break in large electric motors, because the greatest load on the motor and the power supply occur in this case. Furthermore, intelligent speed control reduce the maintenance and servicing costs of the plant many times over, thus saving considerable time and money. How to control speed and torque of the motor? To control DC motor torque, a DC drive will regulate armature current. The armature voltage is unregulated, allowing the motor to operate at whatever speed is necessary to achieve the set current or torque level. How does DC drive control speed? In DC motors, the speed is proportional to the armature voltage and inversely proportional to the field current. And also, the armature current is proportional to the motor torque. Therefore, by increasing or reducing the applied voltage, the speed of the motor is varied. Starting method of DC motors. A DC motor is starting by using a starter. There are various types of DC motor starters, such as 3-pointer starter, 4-point starter, no load release coil starter, and thyristor controller starter. The basic concept behind every DC motor starter is adding external resistance to the armature winding during starting. Why do we need starting method of DC motors? All DC motors are basically self-starting motors. Whenever the armature and the field winding of the DC motor receive a supply, motoring action takes place. So, we do not need any starting method of DC motor by using the starting methods. It enables us to start the motor in a desirable safe manner. At the start of DC motor, the armature draws a very high current of the order of 15 to 20 ampere, which blows out the fuses, disrupt the performance of other equipment connected to the same line, which is for a very short time. To restrict this high armature current, a variable resistance is connected in series with armature of the DC motor at the start, and it is known as a starter or starting resistance. In addition to the starters, more protective devices are provided in the starters. The following are the starting method or starters used for the DC motors explained. 3-pointer starter. When the connected DC motor is to be started, the lever is turned gradually to the right. When the lever touches point 1, the field winding gets directly connected across the supply, and the armature winding gets connected with resistance R1 to R5 in series. During starting, full resistance is added in series with the armature winding. Then, as the lever is moved further, the resistance is gradually cut out from the armature circuit. Now, as the lever reaches to position 6, or the resistance is cut out from the armature circuit and armature gets directly connected across the supply. 4-point starter. The main difference between a 3-point starter and a 4-point starter is that there is no voltage coil is not connected in series with the field coil. The field winding gets directly connected to the supply. As the lever moves, touching the brass arc, the arc below the resistance starts. There is no voltage coil is connected with a current limiting resistance. This arrangement ensures that any change of current in the shunt field does not affect the current through hold-on coil at all. DC series motor starter. Construction of DC series motor starters is very basic as shown in the figure. The start arm is simply moved toward right to start the motor. Thus, maximum resistance is connected in series with the armature during starting and then gradually decrease as the start arm moves toward right. This starter is sometimes also called as a 2-point starter. There is no load release coil holds the start arm to the run position and leave it when the voltage is lost. That's all from us. Thank you.